screen there is an option called whiteboard where
Of
we.
course, of course, of course. The whiteboard, the equations are very difficult to write, right? So normal text it can be right, normal numbers can be right, but the derivation, suppose if the italic numbers and the do by do, those cannot be written. Otherwise, I would have written the same thing. Whiteboard, if the possibility is there, I can use it. But possibility is not there. That's the reason I'm spending more time for preparing the slides. But that will be very easy to me. No need to put all these things in the slide, and for each step I need not explain. Another better way I found. This is another better way instead of putting simply the textbook and all. Yes. Shall we start? Yes. So this is a technical issue. I cannot do anything. Better you talk to your HOD and what it called the coordinator. The whiteboard with annotate option, it is impossible to write it. Right? Anything else more than this? Yes. Yes. Shall I move? Shall I proceed? Can anybody confirm? Yes. Is my voice audible?
Yes, sir.
Shall I move?
Yes, sir.
Yeah. Your coordinator, sir, will talk to you. Okay. Let me start the class. Right. So in the last class, we have seen about this. Quickly, I revise it. So unsteady state conduction, which is a function of temperature. Right. Yeah, Vinay sir. Sir. Good morning, sir. Sorry
for the interruption. I want to share some information with the students. 1 minute.
So the voice is not clear, sir.
Students, please try to understand the long divisions are not possible in the whiteboard. So we'll try to find out any other technical available in the by contacting with the faculty and all. And please, today and tomorrow, just listen the classes and we'll sort out the issue by Monday.
Okay, sir.
Uh,
Sir, we are unable to hear your voice properly. There is a lot of disturbance. Can you please repeat it again? What's the message?
What is clear? What is clear?
No, sir.
Okay now?
No, sir. Some breakage and disturbance.
Okay, now it is okay.
The voice is breaking, sir. Actually.
Okay, I'll post the message in chat box and that will be fine. Okay.
Okay, sir. That will be better. Yes,
That will
sir.
be good.
Yes, sir. Please post in chat box.
Okay. They could have carry on.
Yes, sir. Yes. Thank you, sir. Yeah. Is my voice audible? Clear?
Yes, sir.
So these are the issues we have discussed. Two issues, which is lumped analysis and which is not a lumped analysis. Of course, these will be classified like this. Lumped analysis if the Biot number is less than 0.1, we go for this. Infinite solids, we go for the Biot number between the range of 0.1 to 100. And semi-infinite solids, what are the error function are need to be used? The Heisler charts are need to be used for infinite case. Semi-infinite case error function, what are those we discussed today. Next, these are the lumped analysis, right? So in the lumped analysis, again we have done, these are the initial conditions, and these are the what is called the mechanism, that whatever heat heat is being transferring, right? Based on that, we have derived the temperature profile equation for it using this integration and all, right? So we have obtained the final temperature profile in the last class, and we did or we gone through some numericals, right? The step one is we need to calculate the characteristic length LC, and then we have to go for with that characteristic length LC, we have to calculate the Biot number. Once calculating the Biot number, we have to check whether it is the lumped analysis or infinite solid. If it is less than 0.1, it is lumped analysis. If it is more than 0.1, then we have to go for the infinite solid, right? Those cases we have to discuss today. And the Fourier number, this is very important. Fourier number can be defined like this: alpha tau by L C square. In different textbooks, different notations will be there. In some textbooks, instead of tau, he has taken small t because he used capital T for the temperature. So for that, you need not to worry. So after substituting this Fourier number and Biot number, also this equation can be deducted like this. After that, we discussed the instantaneous and cumulative heat transfer. This is the instantaneous rate of heat flow, and this is cumulative heat transfer. Right? As I said, for instantaneous heat transfer, rho v Cp into rho T by with respect to tau, if you differentiate, you will get it, and this T will be from the temperature profile equation. After simplifying simple mathematics, you will get this. You're supposed to practice it, right? After that, the total cumulative heat transfer, this is the way you have to get. If you integrate from 0 to tau, qi d tau with respect to the change in time, then you will get the cumulative heat transfer there. Yes, Biot number is used to identify whether the type of problem. What kind of problem? It is a lumped analysis. As I said, right, this is a copper ball and some other body, right? Some other body is there, right? So here, if the temperatures are maintaining uniformly, that is lumped system. I said whether to check whether it is lumped system or non-lumped system or semi-infinite solid, infinite solid. That is the significance of Biot number, and significance of Biot number and Fourier numbers also I have given, right? So it signifies the degree of penetration of heating or cooling effect through a solid. That is the Fourier number, the significance of the Fourier number. Next, we have discussed the numericals, very simple numericals. Step 1. Step 1 is you need to calculate the characteristic length. Then you need to calculate the Biot number. After calculating Biot number, check whether it is less than or greater than or equal to 0.1. Then we have to go for the problem. Whether if it is a lumped analysis, we have to use the equations which we have derived. If it is not a lumped analysis system, then we have to go for the Heath-Leb charts that will be discussed now. So these are the numericals which we have discussed in the last class. I asked you to do this problem, but I did not share this PPT. I'll share today. Try to do this, and if you get any doubts, let me know. Right. These are the numericals which I have done. Right. Here, instantaneous heat transfer also. It is calculated here in this problem. If it is less than 0.1 only, if the Biot number is, this solution exists for less than 0.1. Right. If it is more than 0.1, then we have to go for this some other case that is called as semi-infinite solids. Infinite solids and semi-infinite solids. Right. The situation is very easy. Right. Without charts, you cannot do this problem. Right. I spent almost 1.5 hours to put the charts here in the PPT. Right. I don't need to put any charts there because the data book is available. I can go with the data book. Right. I incorporated the charts. I tried in many ways. Right. That is the extra effort done by me. Yes, sir.
One more thing, sir. Data book is available with the students, already shared with the students.
Share నాకు ఏమైనా పంపించగలరా సార్ అది?
పంపిస్తాను మీకు వాట్సాప్.
ఓకే సార్. Yes, yeah. Okay, right. Infinite solids. What is the infinite solid? That is the thing we have to see. For example, this is a plane wall. This is a plane wall. This is a cylinder, and this is a sphere. Leave about the sphere, right? You don't need to worry on the sphere because you are in undergraduation level. You will get on these two only, right? You must be aware on this at least because whatever, even though it is a spherical thing, you're supposed to use the charts, right? So this is the plane surface, and this side and this side it is infinity. We don't know. This is uneven shape. is infinity, and in the cylinder also this is infinity. If the solids are like this, then what is the case? We have to heat transfer, right? So that signifies the Biot number. If the Biot number between the range from 0.1 to 100, then we treat this as infinite solids. We treat this as infinite solids, right? So for this analysis, if the Biot number is simply between 0.1 to greater than 0.1 and 100, then we have to go for the Heisler charts, right? So what is that? Let us see. For example, if you see, these are the example cases. This is the infinite cylinder, and this is the semi-infinite cylinder. That means, for example, this is also a plane surface. So this is also a plane surface. This is also a plane surface, right? And this is the semi-infinite case. I don't know how much length it is or how much area it is, right? That is semi-infinite solid, and this is the short cylinder, which we have studied in lumped case. In general, this is the lumped analysis. We can say this is infinite solid. We can say this is semi-infinite solid cases, right? For example, this is the case semi-infinite medium. We don't talk about these two here, but for example, I'm showing this is the quarter infinite medium. But a semi-infinite medium means, let us say, Earth. The surface which we are staying, right? That is a plane surface. Underground, it is uneven surface. That is semi-infinite solid. The example of semi-infinite solid, right? Or for example, this what we call casting process, sand casting. Let us say, if you take there is a cope and drop box. There is a screw or whatever it may be. The pouring material will be there. You need to pour it. You will get some object. Sorry, the final object, right? But that is uneven object, right? That is also semi-infinite solid. In that also, the heat transfer analysis need to be done because the molten metal is being poured there, right? Next, this figure also you can see. This is for infinite plate, and this is for semi-infinite plate. Previous case it was for cylinder. This is for infinite and semi-infinite plates, right? There are other. This is a ball, rectangular ball, semi-infinite rectangular ball, right? Like that, there are different shapes. This is the quarter infinite plate, right? In that way, there are many geometries. But in our level, we study only the semi-infinite medium and the infinite medium. These two we study here, right? So now here, Heisler charts are used when the Biot number is greater than 0.1 and between the 100. Right. In case of semi-infinite solids, the Biot number cannot be calculated because the geometry is ununiform. This is the plane geometry, and this is something like this, right? But in case of the what we call infinite solid, this is the infinity, but it has some geometry R or geometry L. That's the reason we can calculate it, right? You have to notice here that in this case, there is you don't need to do any derivation here. Only the usage of charts are important, right? So this equation is important. This is a function of three things. X by L is a non-dimensional parameter. HL by K is a Biot number. Alpha tau by L square, that is a Fourier. This entire temperature is a function of these three parameters, which will be shown on the charts. It will also be shown on the charts, right? So we supposed to calculate this X by L, R by R naught. Let us say if it is cylindrical geometry, R by R, capital R. Let us say. What is capital R means? For example, this is the axis, and this is the capital R. Right? Somewhere here it is small r. At a distance from center line to this, it is small r. That R by R. That also we'll see. Right. So now this is the temperature profile. T minus T infinity divided by Ti minus T infinity. Right. So rewriting this temperature, because we know this Ti or Tx or Tr, right? So this can be rewritten like this. So this is the parameter you find in the charts, like this. Right? So the required temperature is this. The what temperature need to be found. The T naught is the temperature which you need to find. Right? This will be provided in the charts. In the Isler charts are the infinite solid. When the problem is confirmed it is infinite solid, you need not of doing any mathematical expressions here. Everything will be attained from the charts. See, sorry for this. Here it is given R by R. If it is cylindrical object. If it is cylindrical object, the R by R is given. Right. Now, let us see what are those charts and how can we do the problem. Right. Suppose whatever charts I have kept here, those are from the textbooks. In the textbooks, you have to calculate in terms of 1 by Biot number. But in the data book, if you calculate Biot number, it is enough. Right? What is that? I'll tell you. Be careful. Carefully, you listen. I'll explain with the difference. What is the difference between this chart and the Biot number chart? Right. So this is the y-axis, and here it is x-axis. So here he has taken this tau as Fourier number here. Right. In y-axis it is Fourier number alpha tau by LC square. This is taken from different textbook. That is the reason the notations are different. Right. This is Fourier number. Keep in mind this is Fourier number. Here in data book he will be given this as simply Biot number. Simply Biot number. Right. But here he has given 1 by Biot number. Both are same. Don't worry. The values are not same. But the approach, the method is same. Either by going through this or by going simply Biot number, both are same. Right. So here you need to remember only thing is these lines, whatever lines is getting 1 by Biot number. If I use this process, else simply Biot number. This Biot number is like this, it will follow. Like this you will get. Okay, I'll show that also because I got the data book now. So I supposed to upload during the break time. I try to put into mail. Right. So now, so this is the y-axis thing. T naught minus T infinity minus Ti minus T infinity. Don't bother about notations again. I'm telling because he has written here in the previous case T naught minus Ta. Ta is nothing but ambient temperature is. Again Ti minus T infinity, right? So you supposed to calculate, for example, if I know this ratio and Biot number, I can calculate Fourier number, because for example 0.2 is my theta and let us say 80 is done by Biot number. 80 is Biot number, so I can take a scale and pencil, and this is the 80 and this is the this is the intersection point, and I have to draw the corresponding vertical line here, and this is, let us say, 130. The 130 is equal to alpha tau by LC square. Suppose I need to find out the time. I can find the time because LC is given, let us say alpha is also given, material property will be given. Suppose if I know these two, I can find out the third one. For example, if I know this and this, I can find this total value. For example, this is 14, Fourier number is 14, and the Biot number is 3. So 14 and 3, roughly I'm taking, this is the 3, this is the intersection point, and this is the value. Around it is 0.018, like that. Is equal to this value, right? This value will be known, this value will also be known, so you are supposed to find out this temperature. If you equate this ratio, and you'll get it. That is one case. So where this case is, that is important. Where do we have to use this? That's the task, right? So For example, if this is the plate, here I write this as a symmetrical plate. Okay, symmetrical plate, and here the length is 2L. I take. You can take either L or 2L. It doesn't matter, right? So this L becomes the thickness. That means one side is L, another side is L. You can take it total as L. This is L by 2. This is L by 2. Like that also you can take. It doesn't matter, right? So, but most of the literature, they will take 2L. So this side it is L, from this side it is L. So in the one direction we have to calculate. I mean to say in the one way, right? While doing problem, let us see that. So this is the usage of Heisler charts for the wall at the outside wall. That means this is the axis I said. At this point, at x is equal to L. At x is equal to L. I write this as 0, and this is the L, and here it is varying at a distance x like this, and it is reaching L. That means this chart is at x is equal to L. Right? That means x by L is equal to 1. At x by L is equal to 1, you need to use this chart. Right? Suppose if at x by L is equal to 0.3, the ratio you got, how do we calculate? That's important. So for that there is another chart. Beside that there is another chart. Right? See this one. So here you know the value of x by L. Right? Suppose L is some 20 centimeters, x is some 15 centimeters. You can get that ratio. So this x by L value you will get, and you can calculate the Biot number or 1 by Biot number. Anyway, in the data book it will be simply Biot number. In this I am showing that it is 1 by Biot number. Either way are correct. Right. So now you know the Biot number, 1 by Biot number value and x by L value. For example, the Biot number is 1. Right, and the x by L is also 1, somewhere here. You have to identify it is around 0.65. This 0.65 is equal to this. I am knowing this value and knowing this value and this value. I am supposed to find this value. Very simple. Right? So this is for the plate case. At any distance from the center line. This is L, and this is also L. Right? I am doing only throughout this analysis. How the temperature varies. At the center, the temperature is maximum. Right? Slowly it reduces. Let's put the temperature profile. At the center only the temperature will maximum, because if you open it to atmosphere, it cools outside part firstly, and then slowly it cools inside. The temperature is maximum at the center line. Right. So that means, for example, along the length from this center line, along the length, the temperature profile reduces. Temperature is reducing along the length of the plate or along the length of the cylinder. So this is the chart for the plates. For example, let us see one problem. Read this problem once. I give 30 seconds time.
Sir, once again explain that previous chart, sir.
This one?
Yes, sir.
This one or both?
This one,
Yeah.
sir.
For example, see, if this is the case, this is the symmetry case. symmetrical plate, let us say. Anyway, the plate will be symmetrical. Here it is 0, and I need to find out at this point, let us say the temperature at this point, I can do it. At this point, if I want to calculate the temperature, I can, right? With the previous case, with the previous chart, directly I can do. But from this, it is moving at a particular length. I cannot calculate, right? Along the length, I need to calculate. So we should use this chart, right? For that, I need to know this is the length of this thing, that is L. This is the thing length L, right? So I need to calculate the temperature. I need to calculate a temperature at a particular distance here, that is, let us say, x, right? So here I need to calculate the temperature. How do I calculate the temperature? I must know the ratio of this. That ratio is this, right? So this is unknown in our case, but there are known parameters. The L is, let us say, he has given 20 centimeters, and x is he has given, let us say, 5 centimeters from 0 at this particular point, right? So the ratio x by L I can calculate. This is the x by L, right? So that x by L is 5 by 20. How much the value of 5 by 20? What is the value of 5 by 20?
1 by 4, sir.
1 by 4. How much? 0 point? Roughly tell us some value. 1 by 4. How much?
0.25.
0.25. 0.25 is the x by L value. Right. 0.25 is the x by L value. Okay. Now, I already calculated the Biot number. Because with the help of the Biot number only, I can check whether the problem is lumped analysis or normal problem, right? So if you calculate the Biot number, that 1 by Biot number, let us say 1 point, my Biot number is 0.3, that 1 by 0.3, if you do, you will get this value, right? Let us assume my Biot number is, let us say 0 point something, here somewhere it is there, 0.3, right? So this is the 0.3, here it is 0.3, and here it is 0.25, it is 0.2 line, it is 0.4 line, you have to interpolate it. Somewhere here, I just guessing it, you people have to interpolate it, right? So that is the intersection point. From that intersection point, I have to draw the horizontal line, right? I got some 0.95, let us assume this is equal to 0.95. Right? So already I know this temperature, which will be given in the problem. This temperature will also be given. So this temperature is nothing but at x is at Tx at a particular temperature. That is the answer. If you find out the temperature, you will get it.
Sir, now what we got is the value of Tx, sir.
Yeah, Tx is nothing. Yeah, at this particular point, the temperature at this point, from center line to at a distance x, right? For example, if you increase it 5 centimeters to 6 centimeters, right? You calculate 6 by something, 6 by 20. You will get some other value. The temperature which you find at that particular x, that becomes the 6 by 20. Like that. That means along the length you are going to calculate. In the previous case, along the length you cannot calculate. That is, throughout the length you can calculate. That means L by L, not x by L, L by L. Understood?
Yes, sir.
So this is the way. Now, a 60 mm thick large steel plate. It is given as plate, steel plate. Right? So steel plate means we take this is the 60 mm. 60 mm itself we can take a thickness. It has 60 mm. For plate L by 2 we consider. Right here, entire plate length we have to consider 2L. 2L is nothing but my thickness, or I can say L simply. This becomes L by 2. This L by 2 or L for the analysis purpose, right? So this is LC. I can see this K is given, alpha is also given. Anyway, this will be given. Without giving this, we cannot do the problem. Right? There is another way of taking the properties from data book, but at undergraduation level, he won't trouble you. Don't worry. Without giving, this will be given. Right? Initially, at some temperature, Ti. Suddenly exposed to environment, heat transfer coefficient is this. H value is given 50 degrees. T infinity is also given. Determine the central line temperature and temperature inside the plate 15 mm from the mid plane after 44.3 minutes. Central line temperature means at this point at x is equal to 0. This is the central line temperature. This is the outside wall and this is central line temperature. The outside wall temperature. At the same time, we can calculate at a distance x from this. Right. So let us see the solution. Before that, again the same procedure. The procedure is same. As I said, we can calculate the characteristic length 30 mm. Next, Fourier number alpha tau by LC square, because LC is known, we can calculate the Fourier number if possibility is there, because alpha is given, tau is also given 4.3 minutes, convert it into seconds, right? Convert this into also meter square per second. Without converting a meter square per second, you will get wrong value, right? After doing that, else you do one thing, here you convert into, it is in meters, tau is in meters, so this also you convert into meters, but better to convert in seconds, that becomes easy, right? So after calculating LC, yeah.
How should be in hours or seconds, sir? Here divided by 60 they have taken.
No, here divided by 60 means simply he has taken see 4.3 minutes.
Yes, sir.
This was the 4.3 minutes. Minutes
So
to
it should be in
seconds.
hours.
Minutes to seconds.
Seconds means we need to multiply into 60, no, sir?
So it is
Okay.
divided by 60. Then we are changing into hours, no, sir.
No, he has changed into hours because he has substituted this value in hour only. Direct value has substituted because it is in the denominator, right? Meter square per hour. This is in hour. Hour gets cancelled. Understood my point?
Yes, sir.
So this is a meter square in per hour into and I convert this into hour. This hour gets cancelled. Only meter square. This is also meter square. The meter square gets cancelled. You will get a non-dimensional number. That is Fourier number. Fourier number and Biot number both are non-dimensional numbers. It should not have the units, right? Unless you put the proper, no, because our intention is to cancel the units. But better to convert into seconds, that becomes easy for the lumped analysis. That is the reason I ask everyone to convert into second itself, right? If you are flexible with this conversion in minutes and hours, that doesn't matter. But my ultimate intention is you need to get non-dimensional number, right? Unless you convert, you don't get it. Right. Next, Biot number. What is Biot number here? 0.165. Even 0.11 also it is greater than 0. Biot number is greater than 0.1. Then we have to go for the infinite solids. We need to go for the infinite solids. So the problem is clearly defined. We don't need to go for lumped analysis since it is greater than 0.1 and it is between the 100. It is within the 100, 0.1 to 100. Then, dear students, I repeat again, here you don't bother about it. In the x-axis, in this case, in the data book, you will be given Biot number in place of this. In place of 1 by Biot number, it will be given simply Biot number. At the same time, here also, in data book, in place of this 1 by Biot number, you will be given Biot number. Little bit, this curves will change. Okay, so you need not to worry on it. Either way, you can calculate using this. You can calculate using the data book also. Right. Now, the problem is defined. Right. The Fourier number, 1 by Biot number, because as per this problem, as per this problem, as per the textbook charts, I am calculating 1 by Biot number is 6.06, Fourier number is 3.4, and x by L is equal to that. Mid plane means at x by L is equal to 0. See here, this is the mid plane. Here the x by L is equal to 0. So here he is asking you to calculate the temperature. What is the temperature at this point? I don't know the temperature. Right? The temperature need to be calculated for plain water. So what I have to do, again I know the 1 by number. I have to go for the charts. Plain plate charts only I have to go because the plate problem is given. Right? I know this value. I know this F value. This is F. Here he has given different rotation. You know the F value. You know the 1 by Biot number value. Right? At x by L is equal to 0. So at center plan you can calculate using this chart. Right? So you know some Biot number value. Let us see what is the Biot number at Fourier numbers. Can somebody remember it, because I am going back again. Fourier number is 3.4, 6.0. Right? 3.4 somewhere here. Let us say 3.4. That is 1 by Biot number is how much? 6 point something. Something line I find somewhere here. This is roughly, right? Corresponding to this, you find this ratio is equal to let us say 0.6 and roughly 0.6, right? T infinity is given in the problem. Initial temperature some 400 is given in the problem. This T naught becomes the central line temperature. At the middle, the temperature is calculated using this. That's the very simple. In the lumped analysis, at least you have to use the problems and you need to do little bit calculation, right? So that is first case. Next, second case, what he is asking, temperature in, this is the thing, some around 0.6 you got. You try it. I'll share this PPT today itself. To complete it. My intention is after completing the PPT, I want to share it actually. That is the reason. Right. So this is the temperature you got, central line temperature. Next, after that, what he is asking, this is the central line temperature, right? And he is asking, this is the L. This is the L. The L is 30. This total is 60, and L is 30, and L is 30. Right. So this is 30, and 15 mm at a distance 15 mm from center line. What is the temperature he is asking? So you are supposed to calculate the x by L. I said x by L. X is 15, L is 30. You will get 0.5. At x by L 0.5, and Biot number you know already from here, right? From the charts, the second chart. If it is a central line temperature, I have to use the first chart. If it is at a distance some value, then I have to go for this chart. For example, let us say what is x by L, 0.5 and 6. See, this is 0.5, 6. This one is 6. 2, 3, 4, 5, 6. Somewhere here. Change the color. And 0.5 ఇక్కడ line you have to interpolate it, right? You will get అంటే rough గా draw చేస్తాను. You will attain some 0.95, let us say. That is equal to 0.95, right? You know this, right? Here you don't get confused. Earlier the initial temperature was different, but here the initial temperature becomes T naught. That becomes the initial temperature. With reference to the central line temperature, you need to find out. That's the reason you have to put T naught here. That is the major mistake students will do. Initially the inter body temperature is something, But after calculating with reference to this only, you have to calculate T naught. Whatever T naught we obtain, so 284 something else. Right? That temperature need to be calculated. With reference to that temperature, we need to calculate. Suppose, for example, at a distance, suppose 20 mm, then what becomes the T naught? The T naught becomes the temperature at a distance 15 mm. At a distance 15 mm. Like that, you have to keep on change it. Otherwise, you will get the wrong answer. Right. So this is the case we need to use for the at a distance particularly at a distance 15 mm or at a distance 16, 17 like that. Right. We can calculate at every 1 mm and we can see what is the variation. And then, for example, if it is at outside surface, the previous case is at the center line at x is equal to 0 chart. Right. This case is at x by L is equal to 1 also we have to use. So x by L value you will get 1, let us say. The Biot number as we take some same value. That means the question will be asked, what is the outside temperature? Outside surface temperature. Outside surface temperature means it is at x is equal to 1. Sorry, at x is equal to L. That means x by L is equal to 1. Then you will find out the temperature. Anyway, the temperature is lower and the minimum temperature in the problem. Right. So this way you have to calculate. See here I substituted at 284. This 284 need to be substituted here. You see this problem, you will understand. The easiest problems I am putting. Better way of understanding problems only I am putting. And this is another problem. Right? The similar problem only. You do it. I give it. If you get any doubts, let me know. See, the maximum permissible time in these surroundings is a little bit different. In the previous case, he has given time. Here he is asking you to calculate the time. Right. Next, inside surface temperature under these conditions. What are the inside surface temperature and all? It is given. This is ulta problem only. Right. See here from the equation which I have shown in the starting of the infinite solids, based on that equation. So this value will be taken from the chart, right? And these values are known. We'll get this. After getting this, if you know this value, that means y-axis value you know. 1 by Biot number also you will be calculating. The only thing is you need to calculate the Fourier number. That means you know y value, you know this chart value, you have to calculate the corresponding f naught value. Ulta only. Right? Because I need to calculate time here. Where the time is there? In which equation is time? The Fourier number equation only we have the time. Alpha tau by L square. Right? In that line we have to move. You go through this problem also. If you get any doubt, you are open to discuss in coming classes. Right? This is the way you can calculate the temperature inside the surface temperature. That means x by L is equal to 0. At x by L is equal to 0, what is the temperature you are supposed to calculate? It got around 1100 degrees centigrade. Right. As like what it call cylinders. Plate. We have to go for the cylinder. Very simple. Very simple. Input intente. See, calculate Biot number H R naught by K. With radius you calculate. Okay. Calculate the H R naught by K values. At the same time here also to check the condition whether it is lumped analysis or infinite solid, then use the Biot number original equation with the help of the characteristic length. Calculate the characteristic length of a particular what it call cylinder or sphere. But when you come to the charts, because that is not designed for the character based on the characteristic length, even in the textbook, even in the data book, we have to aware of it. this Biot number need to be calculated with respect to the radius HR naught by K, not LC by K. Keep in mind, right? So at the same time, because this has been designed for that, that is the reason. There is no any other significance here, right? So alpha tau by LC square we have taken in case of plate. In plate it was designed like that only, as per the Biot number only, as per the characteristic length only. But when you come to the cylinder and sphere, you need to substitute R naught, alpha tau by R naught square, not LC square. Here also, the Biot number, Biot number is nothing but HR naught by K. 1 by Biot number is equal to K by HR naught. In previous case, K by HLC. Right? So, due to some complications, they have designed like this. Right? That is the reason I am telling. Simply I can go on like that, I can show it. But what are the complications we face? Those complications I am elaborately explaining you. Right? So, the same way, the calculation is same. 1 by Biot number, Fourier number, based on these equations, you need to calculate the same procedure. Procedure is same, but in place of cylinder, you will get in place of plate, you will get the cylinder. Right. This is at R by R is equal to 0. That means at central line temperature. This is the cylinder, the infinite cylinder, like this. Right. R by R is equal to 0. Sphere, it is cylinder, that's all. That is the difference. Next, it is at a distance R. For example, this is cylinder I had. This is the radius R, capital R, from this 0 to here. And at a particular distance R, 0 to at a small distance. Now R indicates like x, small x. Right? So R by R you need to calculate. R by R is 0 at central line. If R by R is 0, previous chart need to be used. If R by R is 1, this chart need to be used. If R by R is also having some values from 0 to 1, greater than 0 and 1, then this chart needs to be used. Right. The similar way for the spherical objects also. If the spherical problem also is given, you can use the same charts. There are separate charts for those also. I'll show that also. See, these are the charts for the sphere. What is the sphere radius? Radius you need to take. The Biot number calculation is based on LC only. I repeat again. But when you come to the charts, the Biot number BI need to be calculated in terms of HR naught. Right. This is for the central line temperature profiles, and this is for at any place outside surface would also be. Right. So now let us see one problem on long cylinder. This cylindrical bar, so that you can understand, you can do it. A long cylindrical bar, material properties anyway they will be given, of radius 80 mm. Keep in mind 80 mm is the radius, not diameter. Out of oven at 330 degrees centigrade. Initial temperature is given throughout and is cooled by quenching in it a large bath of 40 degrees centigrade. This is the ambience, the bath ambient temperature or fluid temperature. Right. The surface coefficient, heat transfer coefficient is this one. Determine the time taken by the shaft center to reach 120 degrees centigrade. That means T naught minus T infinity divided by Ti minus T infinity. If this is the temperature 120 degrees centigrade, what is the time? They ask you to calculate time. Right. The surface temperature of the shaft when its central line temperature is 120 degrees centigrade. Outside surface temperature you need to calculate. This is the outside surface. This is the central line. If the central line temperature is 120 degrees centigrade, what is the temperature he is asking? Right. Also calculate the temperature gradient at outside this surface to the same extent. What will be the temperature gradient from here to here? It is a, that means here it need to be convect. Outside surface temperature means it need to be convect. That means minus K into area into dt by dr is equal to HA into delta T. Ambient temperature is 40 degrees centigrade. This surface temperature you need to calculate because it is given in our question. If you know this temperature difference, you'll get area, surface areas gets cancelled, right? Thermal conductivity is given, H is given. You can calculate dt by dr. He is asking you to calculate the gradient, temperature gradient. Right? The same I will show. The same solution I will show. Indirectly, I am explaining the problem twice. Right? If it is a same kind of problem, same model problem, I'm focusing. I'm not focusing that much because this light explanation I'm giving, and I will ask you to do. Right. So this is the equation. Right. Because this temperature is given in the problem. These are given. You will get the R by R naught is 0. I know central and bar is 0. Suppose if I know this value and R by R is 0, right? Can I calculate the Fourier number from charts? Obviously. R by R is 0. This value is known. I can calculate F2, the F value. Since the Fourier number is equal to alpha tau by R square, I can calculate tau because I can calculate from the charts. This is known. This is known. R by R is known. Right. So tau can be calculated in hours or in conversion. In seconds. Temperature at the surface Ts, outside surface, that means R by R is equal to 1. Right. R by R is equal to 1. See here, R by R is equal to 1. You know the Biot number. First step, you need to calculate Biot number here. I forgot to explain. If it is greater than 0.1, then only you have to go for the semi-infinite solid. Sorry, not semi-infinite. Otherwise, semi-infinite. So otherwise, lumped analysis. Right. Again, you R by R1, 1 by Biot number, you know, you will get the temperature there because he is asking you to central and temperature. This is the temperature. Right? The temperature is 106.4 degrees centigrade. Sorry, outside surface temperature, not central and temperature. Central and temperature is given 120 degrees centigrade. This temperature is 106 degrees centigrade. Definitely that need to be lower than this temperature. It's 120 because at the center the temperature is more and towards this outside surface the temperature is less. That is the reason it is 106.4. Next, the gradient. See, as I said, dt by dr. From this we can calculate dou T by dou. As I explained in the before this problem. While reading the problem, I explained. In this way, you have to calculate the gradients. Right? So this is the cylindrical problem. Spherical also is process same. That is the problem. Due to this reason, problem or right. So is given. Here put a problem apple is spherical shape. It is a fully round apple. Ideally, is anyway, the shape of the apple we assume sphere. And we go through this problem. The Biot number, I got the number more than 0.1. So definitely, this cannot be lumped approach cannot be done. We have to go for the Isler chart since it is below the 100. This is the case. This is about the infinite solids. Very easy. Lumped analysis very easy. The people, those who can handle the problematic things, the equations, right? Those who are aware of these charts, this is very easy. Right. Now I go for the infinite solids, semi-finite. Right. This is the case we have discussed. This is the semi-finite solids. I am showing the figure again. Previously, I have shown this. Right. So now there is no much difference. This is the semi-infinite solids. There is no much difference. The only thing is, people very easy to remember this equation. this temperature profile equation you must remember. No need to remember. It's given in data book. Right. So we don't have any scope to calculate the Biot number because the geometry is not uniform in the semi-infinite solids. The Earth surface geometry is not uniform. Suppose, for example, as I said, the what is the casting product? Whatever molten metal you pour in the sand casting, whatever output product, it is not a proper geometry. It is uneven shape. That is the raw material. After moving through certain operations like turning and milling, shaping, then only you will get it to end product. Right? That is the raw product. And what is the heat transfer analysis? What is the time we need to calculate such bodies? That is called as a semi-infinite solids. Right. So here this is Tx of tau. That means here what is happening along the length, the time. Along the length, the time, temperature. The temperature is a function of along the length. Let us say this is the, for example, plane surface. We stay at the plane surface. From that we are going underground. Underground is uneven surface. Right? It is exposing to the underground temperature or whatever temperature it may be. Right. So here ERF of Z you have to use. These two are same equations, but the thing is taken from different sources. ERFC, error function actually. Right. So what is error function? That also let us see. So Z is nothing but x by 2 into root over alpha t. Alpha is thermal diffusivity, tau is the time. This x is nothing but the penetration depth. Directly we can call this length, but for example, if this is the Earth surface and this is the underground, and at a particular depth of x, at a particular depth, what is the temperature and what is the time taking that need to be calculated. That is penetration depth actually. Right. So, or we can simply say depth of the particular object. Right. So what is the Z? The Z is equal to x by 2 root alpha tau. 2 root alpha tau. Dear students, is my voice audible? Dear students, is my voice audible?
Yes, sir.
Yeah. Okay. Just 5 minutes. After 5 minutes, I'll give break and I'll go to new topic. Don't worry. Let me complete this. That is the reason, because in this flow only we can understand what is the difference between that and this. That is the reason I am continuing, not to trouble you or not to complete the task. Okay, right. So this need to be important equation, right? So now we have to use a chart here. That is called as error function chart. So what is Z? What is ERFZ?
Thomas and Vinky.
Venki.
Anything is there? Yeah. So what is Z and what is ERFZ? Right. So if you know the Z value, you can calculate ERFZ, because I need to know the ERFZ. If this ERFZ is, let us say, 0.93. I know this temperature. I know this temperature. I can calculate this temperature. That is easy to do. Right. Same like charts, but this can be done with the help of charts at the same time with the tables also. I will show that. See here. This is Z, my meaning. Right? And this one is temperature. T is X with respect to time. I can calculate this value. Right? So it is better to avoid the chart here. Table is very easy. Right? So the post-graduation problems, this will be a little bit depth. That is the reason these charts will be used to understanding, for better understanding. I am showing this. Now I go to the charts. Right. See, here this is Z, this is here. If you know the Z value, you can calculate ERFZ. The corresponding ERFZ you need to substitute. And temperature profile is equal to some T of x tau is minus T infinity divided by Ti minus T infinity is equal to ERFZ. The ERFZ is equal to some value, let us say. Right? Unless you know the Z value, you cannot calculate the ERFZ. What is Z? Z is nothing but x by root alpha tau. Right? So, problem is the this is Z and this one is error function Z. Right? See, this is Z value. The first column is Z. The second column is this total error function value. Z is nothing but this value. I have shown you. Right? You must know the x value. You know that 2 is constant. Alpha is given time. Right? Like that, you can calculate the Z and AR of Z values. Let us see a problem so that we can see. The steel ingot, which is uneven shape, let us say, heated uniformly to temperature of 745 degrees centigrade, is hardened by quenching in a heating and pot maintained at 20 degrees centigrade. Right? So that is this 745 is the initial temperature. Here, this is Ti. Right? Next, this 20 degrees centigrade is T of A of T infinity. Right. Next, determine the length of the time required for the temperature to reach 595 degrees centigrade. That means if this temperature is also given. This temperature is also given, and is asking you to calculate the time. If the depth is 12 mm thick, the depth is x. Convert it into meters. Right? Is asking you to calculate this. Is asking you to calculate this. Right? For example, here reversely we have to do. Don't bother about this. Skip it. Yeah? Here I know this value. Some value I got. Let us say 0.79. This 0.79 is equal to ERFZ. This totally ERFZ. The ERFZ is equal to 0.79. Then what is Z value? I need to calculate. Right? So let us see that. 0.79 is ERFZ. Where is ERF 0.79? Here somewhere it is 0. Sorry. Somewhere around between this. Here. Okay. So 0.79 ఉంది. 79 దగ్గర అంతా Z value అంటే 0.18. Let roughly తీసుకుందాం. Interpolating చేయండి. Z value is 0.18. Right. ERF Z value I know. That is the ratios of temperature is equal to ERF Z. Based on the ratios of temperature, I calculated this. So I got this that equals to ERF Z. From that, the corresponding value is Z, 0.18. Rough value is 0.18. Right? So some value you got, let us say 0.79 like ERF Z, you got it. Okay. What is the Z value? You got 0.9. 0.9 from tables. How much you got? The value there? 0.18. This is the wrong value. Okay. You know the ERFZ 0.79. Calculate the Z value. Corresponding table. From this is Z value. This is ERFZ. If you know this value, corresponding Z becomes this value. This total value. Right. So X by this total is 0.9. Some value we got. This is wrong. Right. So my intention is to calculate tau. Squaring on both sides. Squaring on both sides. This value is given 12 mm. Alpha is given. This is known. 2 is constant. I only think is tau. Tau is equal to x square. X square is 0.01 because 12 mm given. Right? We can calculate tau. For example, he has not given the ERFZ value. He has given all these parameters, Z value. Then you are supposed to calculate ERF. That is another way. Right? Simply there are two columns. By giving him Z and ERFZ, right? If you know this ERFZ value, you can calculate this. If you know this Z value, you can calculate this. Ultimately, it must be equal to this. Right. So see another problem that is different than this. See here. Is proposed to water pipes underground well, soil initial temperature 5.4 degrees centigrade. At the temperature of surface soil -60 degrees centigrade, and the time is given 9.5 hours. Determine the minimum depth at which the pipe will be laid if the surrounding soil temperature is 0 degrees. Right? That means to reach the 0 degree centigrade, this is 0 degree centigrade. What is the depth is asking the target. So all the temperatures are given here. Right? Again, we will get the ERFZ value. That means this is ERFZ value. If you know this ERFZ value, I can find out the Z value. This is the Z value. Right? I can equate this Z is nothing but this. Right? So time is known, alpha is known, 2 is constant. I can calculate the X value. Suppose in some other problem, he is asking you to calculate this temperature only by giving this parameter, these parameters, and this parameter. X is given, time is given, this is given. Right? So you can calculate Z. Simply Z, if you know the Z value, what is ER of Z? The ER of Z you cannot calculate in the calculator. That's the reason we need to take it from tables. So ER of Z, the corresponding ER of Z need to be substituted here. This value will be given, this value will be given. The only thing is this is the unknown. Not for this problem. In some other problem, case 3, there are only 3 possibilities of problems. Either to find out time, either to find out X, either to find out this T. That's all. That's what unsteady state heat transfer. If you have any questions, let me know. With this, completely, the second unit is ended. Right? Don't worry. The conduction is the large unit. It takes a lot of time. Better understanding of conduction, right? Convection, it is okay. The remaining unit, don't worry. Those are easy units only. They simply applications and calculations, doing problems only. Any questions? Can anybody spell out? Speak out. Any questions? Can somebody respond? Sir, please post notes. Yeah, surely. Surely, definitely. After this, at 12 o'clock, I'll post it. Shall we take a 2 to 3 minutes break? Yeah?
Sir.
2 to 3 minutes only, not more than that, because we have half an hour only. I'll start it again 11:30. I stop share this. See, due to some technical issues, I cannot explain the data book today. So anyway, the data book is with us. So don't worry. You can do anything with the data book. I make you habituate this, right? It's very easy, very easy. So whatever so far we have discussed, right? I'll tell you. Without data book, you cannot do the convection. Even conduction also. Conduction you can simply you can remember the formulas. Convection you cannot remember the formulas, right? So now is the screen visible?
No, sir.
Screen కనిపిస్తుందా?
లేదు సార్.
Okay, one second.
జస్ట్ స్టార్టెడ్ స్క్రీన్ షేరింగ్ అని ఉంది అంతే.
Now is it okay?
Yes, sir. Convection heat transfer.
Very good, right. So this is unit 3 actually. So I see very easy subject and very useful to your life. These subjects. Okay. The individual topics also you will be knowing when you go to industries or some further studies.
చెప్పరా?
Right. So please mute yourself.
యూనిట్ 2 అయిపోయింది కదా.
Yeah. Convection heat transfer. We know what is convection, right? We know what is convection. Before that, we need to talk some basics. What are those basics? You people have studied fluid mechanics.
Yes, sir.
Yeah. If you are studied fluid mechanics, 50% of the convection is over. Right? The same topics will be repeated. Right? Will be knowing. Right? The radiation and heat exchanger is little bit different, but this is already you have studied. These are the topics to be covered in convection, because I cannot say completely this is third unit, because some part of convection is in fourth unit, right? So some part of the convection is in fourth unit, hence we can move completely. We can move, right? In as per this third unit topics concern, the fluid flow concepts, dimensional analysis, boundary layer theory, continuity equation, continuity, momentum and energy equation. Just a minute, Vinay sir is calling. Yeah. So fluid flow concepts, dimensional analysis, boundary layer theory, continuity, momentum and energy equations. Forced convection, external flows we have to study, and forced convection, the internal flows, and free convection will be in the next unit. Right. The convection purely based on the Nusselt number, non-dimensional number. జాగ్రత్తగా నసల్ట్ నంబర్ అది ఏంటి? Without Nusselt number, no convection. Right. See, this continuity and momentum equation we have studied in our fluid mechanics. Right. So just I give outline of this. That's all. I don't want to derive it. One Karman integral equation. You studied it. Right. If you know the momentum thickness, energy thickness, shear stress, and all. Right. I will give the basic ideas of fluid. Then I'll go to, because the boundary layer, there are two types of boundary layers: the hydrodynamic boundary layer and the thermal boundary layer. Definitely one question from GATE. In GATE, one question you'll get from this convection. Hydrodynamic boundary layer we have entirely studied in fluid mechanics. Now you have to study the thermal boundary layer. Right. So this dimensional analysis also you have to study. You have studied, but I just remind you the Buckingham's pi theorem how to do, because for the flow problems you have done it, but heat transfer problems how to do also I'll tell you. These are the things which need to be discussed in this unit. We know convection, the definition of convection, and the modes of heat transfer itself we have studied. It can be classified into two types: natural convection and the forced convection, depending upon the fluid motion. At the beginning only we defined it, right? In the forced convection, fluid will be forced over a surface or inside a surface. If it is external surface, over a surface. If it is inside a tube, you are pumping ladder with the help of some pumps and all. The forcing means that is forced convection. In natural convection, any fluid motion is caused by the natural means or because of the buoyancy and density difference. Right? How that happens also we'll discuss elaborately in the natural convection or free convection case. And that is the difference between it. Forced convection because of some external force device. Right. So convection also called classified into external and internal IC. That means when it is moving over the surface, external. Moving inside the surface, internally. That is internal convection. There are two types of convections: natural convection and forced convection. And according to their geometry, we can say it is external convection and internal convection. Right? External convection, forced and natural convection. Internal convection, again forced and natural convection. Both will be there. Right. So this is the familiar figure. Right? Forced convection. I am using some fan to blow the air over it. This is the surface. The surface temperature is 50 degrees centigrade, and this is 20 degrees centigrade. And the heat transfer takes place. We have given some temperature profile like this in the previous class. If this is T 50 degrees is greater than 20 degrees centigrade, the surface temperature is more than this. Right. So the second case is the free convection. Free convection is though there is no any external device. The air is because of the density difference or buoyancy effect. How that mechanism also takes place, I'll explain, don't worry, in the natural convection. And this is, there is no convection current, simply it is a convection. From this to this point. There is no fluid motion. For example, there is a water over here, there is no flow of water. Right? This is the surface, and this is, there are no convection currents. That is convection. And again, to define to differentiate the convection and the convection, I put this figure. Right. So the reason for bringing this Nusselt number too early, without going to in-depth convection analysis, Nusselt number is equal to HL by K or LC by K. ఈ HLC by K ఎక్కడైనా చూసారా మీరు? ఇప్పుడు చెప్పిన దాంట్లో, ఇప్పటివరకు చెప్పిన దాంట్లో ఎక్కడైనా విన్నారా HLC by K? Can anybody talk? Anybody? A0308.
No, sir.
No. What is Biot number? Biot number is nothing but HLC by K. Adi HLC by K. Biot number also. Right. So Biot number also HLC by K. But the difference is H is same, convective transfer coefficient. LC is characteristic length. That characteristic length will be calculated according to geometry. So here this LC is nothing but the height, simply height. Right? That is LC. Here this K is K of fluid. Here this K is K of solid. In convection, Nusselt number is equal to HLC by K. HLC by K, the K is nothing but fluid thermal conductivity. How to take that fluid thermal conductivity also I will tell you. Right? So that is the difference. The equation is same. Biot number, Fourier number equation okay. HLC by K only. Because this is the non-dimensional number, this is also non-dimensional number. You don't get any units here, but it has the individual application. Here the fluid, here the solid. Here this is based on the geometry we calculate. This is we can say simply height. For example, if you take the radial or cylindrical thing, HR by K or HD by K. Sorry, not HR by K, HD by K. With respect to diameter we calculate. Right? దీనికి సంబంధం లేదు. దీనికి ఎట్లా వాడాలో అలా గుర్తుపెట్టుకోండి, దీనికి ఎట్లా వాడాలో అట్లానే గుర్తుపెట్టుకోండి. కన్ఫ్యూజ్ అవుతారని కన్ఫ్యూజన్ అవాయిడ్ చేయడానికి ముందే చెప్తాను. రైట్, whenever it is required, use Nusselt number. Without Nusselt number, there is no convection, whether it is natural convection or forced convection. Right? The Nusselt number is equal to a function of Reynolds number and Prandtl number in Prandtl number. It is forced convection. Nusselt number is a function of Reynolds number and Prandtl number in forced convection. Nusselt number is a function of Grashof number and Prandtl number. That is natural convection. What are these non-dimensional numbers? Let us see one by one later on. Right? That means we have to derive the using the dimensional analysis for this. Nusselt number is equal to a function of Reynolds number and Prandtl number in the Ravali. Nusselt number is a function of Grashof number and Prandtl number. You need to get Grashof number and Reynolds number. See the difference. Prandtl number is common. Here the difference is here we have to use Reynolds number. Here we have to Grashof number. This is for natural convection, and this is for forced convection. In both cases, HLC by K. This Nusselt number equation will be in the form of Reynolds number and the Prandtl number. That means, for example, 0.332 Reynolds to the power of something and Prandtl to the power of something is equal to Nusselt number. ఈ Nusselt number calculate చేస్తే మనకి H రాదు. H రాకపోతే Q is equal to HK delta T. To calculate heat transfer, this H is important. This H is a function of Nusselt number. This Nusselt number is a function of Reynolds number and Prandtl number. So this is interlinking process. This is interlinking process. The Reynolds number depends upon the number of properties like fluid property, flow property, and geometric property. Prandtl number, mu Cp by K. Why Prandtl number here? Because the heat effect of heat is there. In the previous case, you did not you didn't hear about the Prandtl number in fluid mechanics. You heard about the Reynolds number only. That is only based on the fluid geometry and flow. But when it comes to the Prandtl number, there is effect of heat transfer also. Right? That's the reason. The Nusselt number is very, very, very important. The Nusselt number is a function of Reynolds number and Prandtl number. Right? And the Reynolds number is function of properties. I said flow, fluid, and geometric properties. You can say this is internal and external flow. Everything outside flow, the fluid which is flowing outside the surface. Outside the surface, that is external flow, and if it is flowing internally, it is internal flow. As I said. Next, types of flows: viscous flow and inviscid flow. The fluid has viscosity, viscous flow. If it doesn't have viscosity, inviscid. Internal versus external. Just now I have shown the figure. Compressible or incompressible. Compressible, the density is not constant. In the incompressible flow, the density is constant, rho. Laminar versus turbulent. The laminar, the fluid particles are in well-defined path. The turbulent flow, it is a zigzag path. Right? So, for example, if you open your tap in your kitchen slowly, the water flows slowly in a uniform manner. That is called as the laminar flow. If you open it immediately, it sprinkles. It spreads like a nozzle. Then that is turbulent flow. Right? That is turbulent flow. Next, natural versus forced flow. Natural flow means without any aid of the external device, fan or blower or pump or anything. Forced means opposite to that. It need to be used. Right? The external device need to be used to circulate the fluid. Next, steady versus unsteady state. So far we have studied. Steady is nothing but it doesn't change the temperature, the fluid properties. It changes with time. Right? Next, one-dimensional, two-dimensional, three-dimensional. These also the function of x, y, z. Fluid flow is the function of x, y, z. It may flow in all directions. Suppose if it is y direction, it is 0. Y and z direction, it is 0. That becomes one-dimensional flow. Like that, we can study it. What is the stream function? What is the streamline? All those things we have studied in fluid mechanics. Right. So this is the famous topic. Without this, there is no meaning in fluid flows. Can anybody tell what does this figure tells about? Anybody can?
Newton law of viscosity, sir.
Very good, very good. Newton's law of
Viscosity.
Whenever there is a solid-fluid interaction, as I explained in the beginning, right?
Yes, sir.
I have given some introduction on it. When the fluid is flowing over here, it forms a boundary layer, I said. Right. So what is boundary layer? Also, let us see. Don't worry. Right. So at the surface, at the lower surface, the velocity is 0. Right. So when the fluid is flowing over this, when the height is increasing, what happens to the velocity? The velocities keep on increasing. Velocities keep on increasing like this. Right. That means there will be a shearing action between two fluid particles. This is one fluid particle and this is one fluid particle. Let us say this velocity of this is u and velocity of this is u plus du. There is another fluid particle is there, u plus 2 du. Right. The difference of any two fluid particles will be du. For example, if I take the difference of these two, if I take the difference between these two, again this becomes du. Right. The distance between, assume that the distance between the two fluid layers, that is dy. Then, according to the Newton's law of viscosity, the shear stress, that means the fluid is shearing each other. The two particles is in roughing each other, is directly proportional to the velocity gradient. The velocity is nothing but change in velocity. This is right. Temperature gradient is nothing but dt by dx. Here velocity gradient is nothing but with respect to thickness. Right. So this is the Newton's law of viscosity. The shear stress is directly proportional to the velocity gradient. Or shear strain we can call this as, if you are aware of what is called solid mechanics. Right. So if you remove the constant, tau is equal to mu into du by dy. So this mu is nothing but the dynamic viscosity or absolute viscosity. The SI unit for this is Newton second per meter square, or the another unit, MKS unit, it is Stokes. Poise or Stokes? Poise. For kinematic viscosity, it is Stokes. Right. Kinematic viscosity, it can mu is equal to mu
Dynamic viscosity by density.
Density.
Yes, sir.
Right. These are the very important fundamentals, because the convection is purely based on the fluid. Even though it is interaction of solid, there is a existing study of fluid is needed. Unless we cannot see it, unless we cannot predict the change. Right. So here the kinematic viscosity mu density, all parameters are very,
Led by Manavana.
right? Now, the important topic, dimensional analysis, because you are aware of it. I'll give you five minutes. 5 minutes. Dimensional analysis. Why do you use dimensional analysis? Also, you have studied. No need to go in depth.
Yeah.
So, looking at the dimensional homogeniity of any fluid motion. Your students, kindly mute yourself. Yeah. Right. To test the dimensional homogeneity, to derive the rotational formula for the fluid flow phenomenon, all those things, whatever the application you learned in fluid mechanics, the same thing will be used here. The same uses. Right. So we have training class. When you have training class? At what time? Is 5 minutes okay? 12. Okay.
Beard boy.
Sir,
Yeah.
sir, whether we are going to discuss about Newtonian and non-Newtonian fluids here?
That thing will be discussed will be in the first basics of fluid mechanics. Right? That is the separate subject.
Yes, sir. Sir, as we are discussing about viscosity, so I'm asking, as they support Newton law of viscosity, then we call them, no, sir.
Of course, Newtonian and non-Newtonian fluids, there are different types.
Sir.
Just
Okay,
I'm talking about it because the property viscosity which will be used here. That's
sir.
the reason I just given the difference between the viscosity, density, and the kinematic viscosity.
Okay, sir. Okay,
Just
sir.
that is the reason I tell you.
Okay, sir.
Fluid mechanics చదవాలంటే మళ్ళా it
Yes,
takes
sir.
lot
Yes,
of
sir.
time,
It will be, yes, sir.
right?
Yes, sir. Yes,
So
sir. I understand.
I stopped the class today because many are asking 5 more minutes later, for 2 minutes at least, right? These are the things you must learn. Without the units, there is no engineering. I said already, right? The fundamental for mass, the fundamental dimension is m, length L, time t. In fluid mechanics. The new thing you will be studying here, temperature, theta. MLT theta you should learn here. MLT theta. Right? Tomorrow we'll be doing the Buckingham's Pi theorem, boundary layers and all those things and the uses of data book and all. Right? So these things we have to discuss here because these are discussed already together with this theta for the temperatures. For example, specific heat. If the temperature is there, then we have to use theta also. How to do, let us see. Area. If you don't know units, you cannot write this fundamental dimension. You cannot write the dimension for it. Just you should know the unit. Buckingham's Pi theorem is very easy. Unless you know this unit, no value. Right. Next, there are many things here. Right, you can go through any textbook, fluid mechanics Bansal you have, once revise it, know the units. The moment when I asked it, try to tell these values quickly. Right, because I'll discuss one small problem and I'll assign you to do the natural convection and forced convection Nusselt number. How to do also, I'll tell you. So I stop here, working Pi theorem I'll discuss tomorrow. Next class, probably next class, whenever it may be. Right? So if you have any questions, quickly ask me. I'll confirm. At the same time, I'll send this PPT of second unit completely to Vinay sir. Okay? Any questions?
No, sir.
Right. If you have any questions in solving problems, because I have given the first unit and second unit is half of the PPT also I have given. Right. So the PPT includes the notes, not only a lecture. The reason for putting the problems there is to do you for your benefit.
Sir, once again revise from first chapter, sir.
Once again.
Revise from first chapter.
When?
these
let us
days.
let us complete all the topics we need to be discussed, and let us go back.
Sir, half of the syllabus for first mid, no sir.
Half of the syllabus for first mid. When is your mid?
First mid. I think it's in September.
Okay, let us complete the half of the syllabus first, and then let me revise. I talk to your coordinator.
Okay.
And let us see.
Because some
classes, sir.
Yeah.
Some of them have doubts in the topics. So if you
Yes.
revise, we'll note it down and we'll ask you the doubts.
Yeah,
some topics are not understanding, sir. That's why I'm saying.
Yeah, no issue. Definitely. You do one thing. I share the PPT, right? You go through it, right? Just you mark the doubt wherever you have doubt. Of course, from the beginning only
Yes,
I
sir.
have doubt means I cannot say.
And again, somewhat problem with language.
Which language? English.
Yes, difficult. It's difficult to understand your English language because
My English language you are unable to understand. That means what
Excuse
you
me,
want
sir.
actually. Yeah.
a difficult topic, sir. Just difficult topic. Please discuss in Telugu, okay?
Okay.
Some difficult topics is there, no, sir.
You want to explain in Telugu?
Yes, some difficult topics. It's
Of
important
course.
topics, right?
Yeah, you tell that way. Sir, try to explain in Telugu. I can explain. I can't understand your
Okay.
English means is it in negative way or positive way? That is the reason I am asking you.
Yes, positive only, sir. But difficult topics you have to explain in Telugu.
You have to come forward like that.
Somewhat Telugu, somewhat English. So we can understand everything in heat transfer.